The first factor is surface area. Number two, it's the temperature, or we can say the concentration firstly. Concentration is the second factor affecting the rate of reaction. When concentration increases, it increases rate of collision or number of collision, or we can say probable collision, the probability of collision. When I give you an example, you have a green ball and a red ball in the same medium. When you're hitting each one, the percentage of colliding to shock together is 10%. What happened to the percentage when increased number of green balls to 3 or 4 balls and the red balls to another 3 or green balls? How the percentage of collision increases between them?
Because there's more collisions, because there's
Yes.
more of the particles.
Its probability of collision increases, and so more and more increasing the concentration, it will increase the probability of collision. So when we ask about the concentration, we always will talk about the probability of collision. The hydrochloric acid 0.2 molar, hydrochloric acid 0.02 molar. 0.2 mole diameter cubic is much as concentration, so it is have higher probability of collision between the reactants, so it will increase the rate of reaction. So always when the probability of collision increases, it will affect more on the rate of chemical reaction. When the probability of collision between reactant decreases, it will give or lead to less rate of reaction. So surface area, we will talk about the particle exposed to the medium. Concentration, we will talk about the probability of collision, the possibility of collision. And the temperature, it is the fourth factor. Temperature, from O level, we were studying in O level, you studied the effect of temperature on the particles. Do you know it? What is the effect of temperature on the particles?
As the temperature increases, the kinetic energy increases, which makes more frequent collisions.
Yes, it's move faster and randomly. It moves faster and strongly. So how it can affect on the probability of collision again?
It will increase the probability.
So it will, by increasing temperature, it increase the kinetic energy of the molecule. So it moves faster and randomly and stronger. So giving higher or stronger collision and the more number of collision. The only one technique or the only one factor which should give a stronger collision, it's the temperature. It increases the frequency of collision times of collision, and also increase the strength of collision. So always it increase the rate of chemical reaction. And the last one here, which is catalyst. The catalyst, which is this question talking about. Do you know the activation energy we defined before? Activation energy, it is the minimum amount of energy needed by the reactant to start the reaction. Do you know when the activation energy increases, when more the reactant needed high energy to activate it, it will make the rate of reaction is slow. It will take more time to activate it. When you wanted to activate at 2000 joule or 2000 kilojoule, it will take more time than you want to activate to 500 or مثلا, for example, 900 kilojoule. It will take less time. How we can increase the rate of chemical reaction? By decreasing the activation energy by using a catalyst. This is the rule of catalyst. The catalyst will save this energy, will decrease the activation energy needed by the reactant. You not have to heat all this amount of energy. You just need to activate to 900 energy by using a catalyst. How the catalyst to do that? By close the reactant on its surface. It will be it will collect the reactant on its surface more and more, and make higher frequent collision without need of high temperature. It will save the temperature used. It will be economical in saving than the other, and without using a catalyst. So the curve of activation energy when using a catalyst will be lower than the curve of activation energy without using a catalyst. So again, what is the rule of catalyst? The catalyst lower the activation energy needed by the reactant molecule. So that's make higher rate of chemical reaction. So number B, what is the answer?
Reaction.
Dana, can you hear me? How we can answer
Hello?
number
Yeah.
B? Mhm.
It lowers the activation energy of a reaction.
Lower or it decrease the activation energy needed by the reactant. This is Boltzmann curve. I talked to you about that. Do you know anything about it?
We haven't learnt it in class.
Okay, so let's start to discuss it because there is no question about the rate of chemical reaction will not include the Boltzmann. Boltzmann here we have three areas like this. The first area which is starting the reaction. The vertical columns indicating the number of molecule, the x-axis representing the energy of the molecule, and the first region here expressing number of molecules which start the reaction and their energies. Initially, starting the reaction, you can notice that we have lower energy. This is number of molecules or number of reactants starting the reaction with a low energy. Can you conclude why they have low energy than expected? Initially, the reaction. What make the reactant have low energy starting the reaction? Although we say in the accept activation energy, they accept activation energy, but they still remain in a low energy. Can you deduce why?
Not sure, no.
Because they consume their energies in collision to start the reaction. Starting the reaction, the molecules make hard collision to start the reaction. So they consume most of their energies. So always the reactant started the reaction with a low energy and accept energy by heating or by the activation energy until reach to the maximum here. This area or this peak resembling number of molecule which have maximum amount of energy. When you heating the reactant, you will have some number of molecule or a few number of molecule have maximum amount of energy. And another number of molecules, another area, which have the activation energy, have energy equal to the activation energy. And this area, it is the number of molecule which have energy more than activation. So you can conclude Boltzmann here discuss the effect of temperature on the energy of the molecule. You can imagine previously in all the molecule have the same level of energies, have the same amount of energies, which is wrong. Not all the molecule have the same amount of energy. We have different classification. Firstly, all the molecule have low energy because it start collision, consume their energy in collision, until we have three categories. The maximum amount of energy or number of molecule which have maximum amount of energy in this peak, following by this area which is express the activation energy, the molecules which have activation energy exactly, and this small area which resembling a molecule which is have much higher than activation energy. Can I ask you a question? Dana, can you hear me?
Yeah.
Do you think which is area when
Yes.
which is area when be more larger will increase the rate of chemical reaction? Which is area when increased, it increase the rate of chemical reaction, either this peak of area or the activation area, the molecule have the same activation energy, or this area. Which one, when increased, it will increase the rate of chemical reaction?
The first one.
The first one is not. Always number of molecules which have maximum amount of energy will be less number, will be small area region, will be small total amounts of molecule, but always the number of molecules which have the same activation energy will be higher than any other region. So when the activation energy the region of activation energy molecule increases, it will increase more the rate of chemical reaction. That means that reaction is higher rate. You don't want مثلا one member or two member or three member in your town is the rich is one and the other is poor. But you want to all the community or most of the community are medium state or reliefly state without extreme. That makes stability more. When you have only one or two or three much rich and the other is poor, it's unstable. It is not the right case or the stable case. But when you have most of the numbers or most of the molecules, most of the members have close energy, that make the stability. It's important it reach to the activation energy. When you have most molecules have the activation energy, it's apply, it's provided in those, it will be higher rate of chemical reaction. Then you have less number of molecule have maximum of energy. It does not increase the rate of reaction. So by increasing the temperature always, that will be the shape of the Boltzmann. When increasing temperature, it will increase the area of activation energy. It will increase the area of activation and decrease the maximum activation energy or the maximum molecule have the maximum energy. It will decrease the number of molecule have maximum energy and increase the area of molecule have the activation energy exactly like this. That's how we can increase the rate of reaction by increasing temperature. So Boltzmann here explain why by increasing the temperature, it increased the rate of reaction. Not because the previous explanation, not because the kinetic energy increased and like this, because it increased the area of number of molecule have the activation energy. Can you imagine? Dana, can you hear me? Dana?
Yes, hello.
Okay. Do you hear the last part?
No, you froze.
Okay. Again, we will classify Boltzmann graph into three regions. The first region A, the second region B, the third region C. When we have temperature, يعني temperature of molecule, it will classify into three areas. A small number of molecule have maximum energy. It will be always a small number, which is we call the elite of molecule. Some molecules, tiny numbers or small numbers, they have maximum amount of energy. And the most of the molecule will have the activation energy. Most of the molecule will be the same of activation energy. And that will be good for the rate of reaction. This region will increase the rate of reaction. And a small amount also would have activation more than the activation energy. More than activation energy. Do you think which region is responsible mainly for increasing the rate of reaction? A, B, or C?
Can you repeat, please?
Yes.
You keep cutting out.
Okay. We have three regions. Region A have a small number of molecules which have maximum amount of energy. Like you have elite members in community. 1 or 2 or 3 members which is much rich, and the other members will poor. That will make the community rich? No, because the most community is poor. But what happens when we have most community have the activation energy? Most of the molecule have the activation energy, and يعني it's the most region. It will make higher rate of chemical reaction more and more. We not need to have a small amount of energy, have maximum number of molecule, and the less molecule have a number of molecule have activation energy. Increasing the region of activation energy, increasing the rate of chemical reaction. Decreasing the region of activation energy, decreasing the rate of chemical reaction. So Boltzmann show the effect of increasing temperature. He showed that increasing the temperature of the reaction will increase the region of activation energy. It will يعني make diagram like this. It's make the region of number of molecule higher than the activation energy or maximum energy like this. Increase the region of activation energy. That's make that we have much number of molecule have the activation energy, and that's required for the rate of reaction. So by increasing temperature, the curve will be lower bottom and wide curve in region B. So that increase number of molecule which have activation energy, and that increase the rate of chemical reaction. So Boltzmann curve discuss how the effect of temperature to increase the region of E activation. When the number of molecules have the activation energy increases, that means that the rate of reaction increases. That is the conclusion of the Boltzmann. Okay?
Okay.
How can you discuss then the Boltzmann by increasing temperature? How it
So
can
as
affect on region?
as the temperature increases, the rate of reaction increases, and the molecules are like there's fewer molecules.
We not mention the result firstly, we mention the results finally. So increase the rate of reaction, the finally it is the results. But the reason, because by increasing temperature, increasing the region of activation energy molecule, number of molecule which have the ionization, the activation energy will be higher because its area will be higher on the diagram. So you here increase the effective member. Which is the effective member in the reaction? Which have the activation energy of the molecule. So you already increase that. You increase the number of molecule which have the activation energy. And that's what is needed. You said that, but you lower the number of molecule which have maximum energy. I don't need them. They're not effective in the rate of chemical reaction. A small number of molecule have maximum energy, not much effect, than a large number of molecule have activation energy. Okay?
Okay.
So let's answer. Consider the following change. The number of molecules increased at constant temperature. The temperature is decreased without changing the number of molecules. The catalyst is introduced without changing the temperature or the number of molecules. For each of this changes the state how, if it all following would vary, the value of the most probable energy E. E activation, I think. E MP اللي هي mean probable. The most probable energy يعني how this changes will affect on this area the number of molecule which have maximum amount of energy اللي هي MB. How this changes will affect the value of the most probable energy or the maximum amount of energy. Temperature is decreased without changing the number of molecules. Number of molecules is increased at constant temperature. A catalyst is introduced without changing. All these different factors, how can they affect each one على ال EMB أو ال number of molecule have maximum amount of energy. يعني لو انت increase the number of molecule in a constant temperature, how it can affect on this area, which is contain molecules have maximum amount of energy. You just increase the number of molecules.
It won't change because it's a maximum.
Okay, it will change in energy. You don't change the temperature. So when the temperature not changed, it will not affect the maximum amount of energy. When you not change in temperature, so not change in energy anymore. The first factor will not affect on the energy because there is no change in temperature. You just change the concentration. Okay?
Okay.
So here, changing the number of molecule will not affect the maximum temperature reached by the molecule. It will affect the number of molecule only. The second factor, the temperature is decreased without changing in the number of molecules. We said when increasing the temperature, the curve will shift to the right more, increasing the activation area and decreasing the number of molecules in EMB. So what happened when decrease the temperature? When
the activation will decrease.
the EMB, the energy of maximum molecule will increase. The number of molecules which have EMB, maximum energy, will increase because decreasing the temperature. We said decreasing the temperature more, high decrease the activation energy region and increase the EMB region or area type. But when increasing the temperature, it will increase the activation energy region and decrease the EMB area. So it's adverse to each other. Here it will decrease, will increase. Decrease the temperature, increases the maximum amount of energy gained by the molecule. The catalyst introduced without changing the temperature or the number of molecule. How the catalyst will it change?
I don't know. It will work faster.
The catalyst effect on this region only because the catalyst change the standard of activation energy as we said. The catalyst change a level of activation energy. Without using a catalyst, you need to activate until this heat. This is activation energy. Starting from here, it's activation energy. But by using a catalyst, the activation energy value will decrease. So the EA will decrease, not EMB. Okay? يبقى الكاتاليست affect only in the amount of activation energy. It will decrease the level. It will decrease the minimum amount of energy needed by the molecule. تمام? So that's I said to you, we must discuss it before we solving because it's the most important part.
Is this Edexcel AS?
Yes.
Because my teacher, we did the whole topic and she didn't mention anything about this. All she did was like, she did endothermic and exothermic.
This
And
but that is the rate of chemical reaction. You said the rate or exothermic or endothermic?
no, we did exothermic, endothermic, and we did neutralization and reaction, combustion, formation.
You not have the rate of chemical reaction?
No, we haven't done it.
Unit 1, Unit 2, or Unit 3?
Unit 2.
Yes. Mm, I have to get this review because it's unit 3. Okay. I asked you before I started its rate of chemical reaction or energetics. You said
I said energetic.
okay. So here, okay, it's a lesson in unit 3. Type here we have the energetics. Mm, تمام. Chemical energetics. Enthalpy change. Mhm. What is the meaning of enthalpy?
The heat energy released.
Enthalpy, it is the heat content of the matter. It is the total amount of heat storing inside the matter. So enthalpy, meaning heat content. And by the difference in enthalpy between the molecule, we can get the delta H أو change in enthalpy and detect if it's exothermic or endothermic. طيب أنا هفتح لك worksheet energetics علشان برضو نحل على الجزء ده you ask it. مهم. لا إله إلا الله. Can you see the share screen?
Yeah.
Okay. طيب let's start but I asked you for existence join the same link again.
Okay.
ماشي.